Okay, so we are talking about the types of reactions lab. We were looking at an example that we're going to do today in class, and then a couple more people showed up, so I decided to start the video. And we're looking at another reaction that we're going to be doing, and that is reaction number.
Actually, could you use 7?
Reaction 7.
That's silver nitrate reacted with copper wire.
So we got silver nitrate, which is going to be an aqueous solution, reacting with copper wire. That's going to be a solid. So when we look at this, we say, okay, I'm going to go ahead and do a metathesis. Well, this is actually going to be considered a single displacement. This is not technically a metathesis reaction, right? Because there's not another. I'm just going to have the copper replace the silver and see what happens. So that would make copper nitrate, and it would make silver solid. Now, it's difficult to tell right off the bat whether it should be copper 1 or copper 2. I happen to know in this reaction that's actually going to make copper 2 nitrate. And again, we could, when we take Chem 125, we're going to make sense of that by looking at the standard reduction potentials, but that's a bit further in the future, right? Where we can start to actually look at the energetics of reactions. To define why a particular reaction happens, we need to know more about energy. Which is all Chem 125 is about, really, is energetics of reactions. So I'm going to look at this. I'm going to say I'm going to need a 2 here to balance that, and a 2 there to balance that. This is our reaction. If I wrote down a net ionic equation for this, I'm just going to jump straight to that. I'm going to skip the total ionic. Hopefully you've been practicing your total ionics. I'm just going to jump right to net ionic, because I look at this and I'm like, oh, nitrate's a spectator. I can just see that, right? Silver is going to be changing charge. I'm going to have 2 Ag plus aqueous plus Cu solid is going to go to Cu2 plus aqueous. Ooh, that's not a Q. Aqueous plus 2 Ag solid.
Are you gonna expect us to write like the charge above the element in the net ionic equation?
If it is an ion, yes. If we are talking about, so if we were looking at this situation, I would put this as Ag plus, and notice I put it in a parenthesis when I'm trying to represent the charge in a compound, but overall this thing has a charge of 0. This actually it becomes an ion and has a charge when I'm looking at my net ionic, so you do need to explicitly write the pluses there. When I look at this, I say, okay, what type of reaction is this? Is it an acid-base? Is it a precipitate? Kinda. There's solid produced, but there's a better answer than precipitate.
Was it redox because the charge changes?
Yeah. So again, notice my silver here, and we're like I mentioned, we're going to talk about this in class, but getting ahead is always a good idea. So when we look for the indicator, the sign that there's a redox reaction happening, we're looking for a change in charge. And I mentioned, actually, we already talked about that in class, but we're going to get a lot more detailed with that. So when I look at this, I'm going to say my silver goes from having a plus charge to essentially having a 0 charge. My copper goes from having a 0 charge to having a 2 plus charge. So when I look at this, I can say, oh, change in charge, I have something that is gaining electrons, something that is losing electrons. That is going to be a redox reaction. And we can tell. What was the other one that you wanted to ask about?
I wanted to ask about 5, but I kind of made sense of.
Let's do 5 together, because 5's a good one. What were the reactants in reaction 5?
Calcium oxide and hydrochloric acid.
This is calcium oxide solid. This is hydrochloric acid aqueous. What did you predict as products?
Calcium chloride and sodium nitrate.
Pardon?
What do you think?
I think you jumping between two reactions.
Oh wow, I'm looking at 13. Sorry. I'm looking at calcium chloride and water. Sorry, yeah,
Okay.
13.
Two things to fix on this. Thing number one, should calcium chloride be solid, liquid, gas, or aqueous? Right, we look at the solubility rules, we say calcium chloride and aqueous. Thing number two, did I make a good compound? No, we know from the periodic trends that calcium is going to have a +2 charge. It doesn't really have any other oxidation states, any other charges possible. So if I want to make a good compound, that would be CaCl2 aqueous. So then we can go ahead and look at this and say if I go to my net ionic, again, I'm skipping total ionic. Hopefully we've been practicing enough that I can just go net ionic. Oxides are insoluble. Oh, I already messed up.
What, you forgot to do?
Yeah, I forgot to balance. We should balance before we go to our total ionic or net ionic. And you can see that's going to be a problem because if I write it like this, if I forget that too, I'm not going to have enough chlorines for my reaction. I'm not going to have enough hydrogen for my reaction. So I need 2H plus, 2Cl minus. That's going to go to Ca2 plus aqueous. I didn't give myself enough space, so I'm going to write it a little bit strange. Cl2, Cl minus, aqueous, and H2O, liquid. I'm going to go ahead. Oh, actually, this is total ionic. I didn't go straight to net ionic. I'm going to cancel out my spectator ion. So the thing that's the same number, same element, same charge, same state of matter. Chlorine in that case. So my reaction is calcium oxide plus H plus goes to H2O plus calcium 2 plus. Aqueous, liquid, aqueous, solid. What type of reaction is that? Redox. Yes or no?
Or I don't know, or acid base.
Or acid base. Yes or no?
I wrote acid base. I actually wrote that.
Let's cancel out the one that we're sure it's not. It's not a precipitation reaction, right? Calcium oxide, if we look at our solubility rules, stays solid in water. It's not precipitating. It's not dissolving. There's acid added. That's going to cause a reaction. So say, okay, it's one of the other twos. It's either precipitate or acid base. Not precipitate. Sorry, it's either redox or acid base. Can't be precipitate. Thank you for correcting me. So we look at this and we say, okay, what are the signs that it's an acid base reaction?
There's
There's a sign change.
That's a sign that it's not redox. But we've got an acid as a reactant. We've got water as a product. That's a good sign, but it doesn't guarantee. There are some examples where we have those things, but it's actually not necessarily an acid-base reaction. So let's also make sure that it's not a redox reaction. For a redox reaction, we're looking for a change in charge. Our calcium here has what charge?
+2.
Our oxygen here has?
-2.
Our hydrogen here?
+1.
Our oxygen here?
-2.
The charges aren't changing. The only one not in parentheses is the one that's has actual charge on the ion. So the calcium 2 plus is 2 plus before and after. The hydrogen plus is plus before and after, in reactants and in products. The oxygen is -2 in the reactants and -2 in the products. There's no change in charge. That means it's not a redox reaction. It is an acid-base reaction.
How come you don't split up in the total and the net? How come you don't split up the calcium and oxygen and then the H2O?
So we don't break up the H2O because it has what type of bonds?
Hydrogen.
That's an interaction, not a type of bond.
Then the ion no?
That's an IMF, not a type of bond.
Oh, covalent.
That's covalent bonds. We don't typically break covalent bonds, right? The extent to which we break covalent bonds just happens in acids. Now, for those of you that are reading in the textbook, had this in high school, something like that, you could be like, wait, doesn't water act like an acid a little bit? Yeah, a little bit. Technically, the H2O, there's one of those hydrogen bonds will break, but in terms of its magnitude, it's like 1 in every 5 billion will do that. So it's a really small amount. And I'm off by a couple zeros. It's actually less than 1 in a billion. It's less than 1 in a trillion. It's a very small amount, does that. So we're not going to break the covalent bonds. The only case where we break covalent bonds is those acids, particularly strong acids. So we don't break that one up. For the calcium oxide, we would look at our solubility rules and say, oh, is calcium oxide soluble or insoluble? And this is one of the problems with the solubility rules. The solubility rules don't cover everything. One of the things it does not cover is the fact that oxides are typically insoluble. Oxides are typically insoluble. So calcium oxide is an insoluble solid. Doesn't dissolve in water.
If you have something that's insoluble, you don't break it up.
Correct.
Okay.
We leave it as a solid. Cool. Other questions with this, with the lab, or are we okay to move on to homework questions? You haven't asked any questions yet. Did you have?
Yeah, I missed Thursday, so I kind of this frustrating like when I missed. Yeah, I know it's a lot.
Yeah, you missed a big day. Did you get my email? Did I respond to you?
Yeah, I got it like today.
Okay.
So
Okay.
came in this
Yeah,
morning.
I wrote it this morning. So, you do need to find that there are some classes that are still running types of reactions this week. You're gonna have to find a time to make that up.
Okay.
We can talk about the other things later, but that's the main thing, is making sure, because we did a lot on Thursday.
Okay. Yeah.
I don't know. Do you feel like we did a lot on Thursday?
I mean, like,
yeah.
I mean, you could do the whole.
good
I think
news-
you could do the whole lab without even. I think you could answer all this without actually doing the lab.
Yeah.
But like
The good news is most of what we did Thursday was definitional
Okay.
and conceptual, so it should be easy to make up the concept and definition work. But I find that you missed one of the most fun labs of the quarter. So I would encourage. Yeah, you should find.
Is there
time
time
to do that.
tomorrow that we're working on the lab? Or?
Not really. I'm gonna do 3 demos, and then it's pretty much gonna be due after people write those reactions. So, not much time. Mostly the demos and kind of talking through some examples like this.
you do 6.
Other lab questions, or should we move on to homework?
Good.
Homework. Okay. Let's take a look at some homework problems. So what homework problems do we want to look at? And just to be clear, it's the first 9 homework problems we're working up to the midterm. Stoichiometry, even though we're going to get into some concepts involving stoichiometry today in class, we're not going to have any stoichiometry on the second midterm. But I like being quantitative. We're going to do some qualitative work with limiting reactants, and I also like to include some quantitative work, but the quantitative won't be till the final. Homework questions?
Number. What is it? Oh, 8. Explain the significant difference in the meaning of Cl2 and in barium chloride and in chlorine gas.
the same thing we're
Aha.
talking about?
This is the exact same thing that we were just talking about,
Okay, that's
right?
what I thought.
This is Cl2. What is Cl2 in this case?
Negative one charge. That would be the other one.
If we have just Cl2 like
I'm
this,
sorry, it's the no charge.
yeah, no charge, this would be a chlorine covalently bonded to another chlorine. This is a covalent bond. We could represent the electrons. Really, we should be drawing electron distribution and all that, but that's that. This is going to be Ba2 plus ionically bonded to a Cl minus and then ionically bonded to another Cl minus. Probably not with this angle, probably in some sort of crystal structure, right? Barium chloride is going to have some crystal lattice associated with it, but I don't know the crystal lattice of barium chloride. So this is going to be ionic bonds of two Cl minuses. This is going to be Cl2 covalent bond. And that's the critical thing to understand. Now, how we can change the Cl minus into Cl2, or when we do that gets back to the redox reactions and how we can push certain things to happen. Does that answer your question? That's the core of that question, is just recognizing ionic versus covalent. Dissolves in water, is soluble in water, but doesn't dissolve because we don't break the covalent bond. And only very slightly soluble in water. We'll talk about that more in class today. Other homework questions?
Yes. I'm just looking.
All of problem 9.
Problem 9 was like,
It's not that bad.
well, because you don't have to identify the type of reaction, so that makes it a lot simpler.
What?
That's what it doesn't say you do on it.
Oh, I should add that in.
You want to sit down after this.
Oh, it's
That you should really. Okay, so quick thing. I'm a little heartbroken. I didn't realize the homework didn't do that. I'm going to add it to the homework for future generations. Problem 9, you should identify the type of reaction for each of those as well and justify your identification. I'm not going to put it on the quiz because it's not on the homework. That's why I'm a little heartbroken. I mean, the problem will be, but not the identification. Well, it could be. We don't even have a homework quiz until like week 9 anyway. But
so then,
it's a ways off still.
Would we need that for like the final and the midterm?
You should be able to have those skills for the midterm and the final. You should be able to identify types of reactions given words like that.
well, then,
So even though it's not on the homework, that's a really important skill to practice.
Wait, so if you were to ask us to, wait, what did you want to add to it? The question exactly?
Identify the type of reaction and justify your identification.
So would that just be the 3?
Yeah, out of the 3.
Okay.
Now, one of the things that we didn't talk about in class on Thursday was the background, and even the way we've been talking about reactions. There is what I call the atomic kind of rearrangement types of reactions, which is single displacement, double displacement, decomposition, synthesis. And then there's the chemical, and all of those just have to do with how you're rearranging atoms, not what's actually changing. And then you've got the chemical types of reactions, precipitation, acid-base redox, where you're actually talking about how the chemical compounds change. Those are 2 different things. Okay. I guess short video today, short office hours. I'll still be here to answer questions, but